Alright, so this will be our last example using the definition of the derivative for Math 1560, Calc 1 at U of L for fall 2017. I had one more in mind, but I thought I'll skip it. We'll save a couple of these for class. I was going to do 1 over x squared. I thought we'd do that one, but let's save that one for the classroom, and let's jump into the cosine one. So the other one I will do in class is I'll do the derivative of the sine function in class. And I thought I would do cosine for you guys here. So again, we'll do the derivative at a point, and then we'll do the general result. And as you probably guessed, the general result is actually a little bit cleaner than doing the derivative at a point. So let's say I want to calculate the derivative at pi over 3. So what do I do? Well, that's the limit, h going to 0, cosine of pi over 3 plus h minus cosine of pi over 3 all divided by h. So let me remind you, cos of pi over 3 is 1/2. And you're going to see in a second we will also need sine of pi over 3, which is root 3 over 2. Okay, so how do I proceed? Well, I can evaluate the cosine function on the right. I know what cos pi over 3 is. How do I deal with pi over 3 plus h? Well, I've got a sum of two values, let's say two angles, and I know how to deal with cosine of a sum. There's an identity for that. I get cos pi over 3 cosine of h. Let's put brackets around that h so we don't confuse this with hyperbolic cosine. Not that you guys have to worry about that. The 1565 students, they will see hyperbolic cosine. Sine of pi over 3, sine of h minus, well, let's put that in, 1/2. There's my cos of pi over 3 over h. So let's evaluate the remaining ones that we can do. So I've got 1/2 times cosine of h, and for reasons that will become apparent soon, let me take this 1/2 here and combine it with these guys. Okay, and then I'm left with minus, so sine of pi over 3, root 3 over 2 times sine of h, and the whole thing is divided by h. So I'm going to split this up into two limits. The limit as h goes to 0 of, now in this first one I'm going to pull out a 1/2. I've got a common factor, right? 1/2 here, 1/2 here. I can factor it out. That leaves me with cosine of h minus 1 all divided by h minus, and then my other one I've got root 3 over 2, and then I've got sine h over h. Okay, and of course now the limit properties tell me that I can take the limit of each of these two separately. I can take the limit of this minus the limit of this, and I also know that I can pull out these constants. The other thing that you need to know is that this limit, and we did this one in the trig limits video, we showed that this limit is 0, and of course we know that this limit is 1. So what do we get for our answer? Well, this first thing is all going to go to 0. This is going to be 1 times, what are we left with? Minus root 3 over 2. Okay, and how do we do this generally? Well, notice what was that minus root 3 over 2? That came from this guy here, minus sine of pi over 3. And you probably won't be too surprised to learn that the derivative of cos in general will be minus sine. So here's how it's going to look. The limit, h goes to 0. So cos of x plus h minus cos of x over h. So I get the limit as h goes to 0. So again, I'm going to have to use the angle addition formula to expand the cosine function. So I get cos x cos h minus sine x sine h minus cos x all divided by h. And again, I want to try and group like terms. So I've got two cos x terms here, right? Here I've got cos x times cos h. Here I've got cos x times minus 1. So I'm going to group those together. So I've got the limit h going to 0. Cos x times cos h minus 1. And then I've got minus sine x times sine h. And just like we did in the previous example, when I divide by h, I'm going to divide by h here. Right? Rather than doing a common denominator, I'll split it up into those two terms. And now I can take the limit of this whole thing, and I can take that limit term by term. Okay? And I know, again, that this limit is going to be 0. I know that this limit is going to be 1. And so I get my answer. I get minus sine x. And that's my derivative for the cosine function.